Hello, I'm Nate Latavik,
I'm Brandon Gary.
I'm Tyveo.
and this is our senior project, Machine Shop Tracking System Redesign. Here's a brief overview of what we'll be discussing today in this presentation. We'll start with an introduction to Mustang 60 and the Arrow Hanger. We'll go through our problem statement, give a background, list our objectives, provide some insight to our literature review. We'll show you our solution design, what we did to test and evaluate this design, and then a conclusion and where this project goes in the future. Mustang 60 and the Arrow Hanger machine shops are tech shops available for use by Cal Poly students. They have a host of different tools and machines that are used by students to complete various projects they may have, whether it's in the classroom or for a club. The two shops provide training and certifications for students, and student work records are stored on a shared Microsoft Access database. The current state of this shared database is flawed. Checking in and checking out of this system for students is inefficient and time-consuming. There are a host of different bugs that corrupt these logged hours that students put in and force shop techs to go in and change and debug the system. The data that is collected is not sorted in a user-friendly manner, and it lacks a key function to export this data in a reasonable manner. Our desired state is to design, test, and pilot a new check-in, check-out system, which will eliminate the time wasted by employees and students alike in this check-in, check-out system. And finally, of course, we want to provide a user-friendly and aesthetically pleasing product.
In the past, there have been several attempts to implement a better check-in, check-out system for both the Mustang 60 and Arrow Hanger machine shops. Most of the past attempts have been at trying to make a more unified data sharing program between all four of the machine shops at Cal Poly. The problem with this, though, has been that each machine shop, excluding Mustang 60 and the Arrow Hanger, have different check-in and check-out systems with certification standards. And finally, the current database for Mustang 60 and the Arrow Hanger has a limited data available to its sponsors and potential sponsors. Our objectives for this project are to provide a literature review to aid the readers in their understanding of database management systems, to create an understanding of the current state of the database we will be working with and its accompanying physical operational procedures, identify the inefficiencies and bugs within the current state of the database, provide a redesign of the current database system and accompanying physical operational procedures, and finally to create a functional platform to allow for future expansion of the database. The literature review within our report pertains to the following information. It goes over different types of databases and what each one is used for, the different types of data that can be collected from a project and how to use it, how to design and implement a successful database, and how a successful database fits within the physical space of a system. All of this will help us in being able to implement a new database for Mustang 60 and the Arrow Hanger.
There were numerous tools that we used for this project that we have learned in our industrial engineering curriculum. The main tools that we ended up using for this project branched off concepts learned in database management and system design. For example, we needed to understand the concepts learned about ER diagrams and how the correct way to structure data points into correct fields. Project organization and management was useful to manage the timeline of the project and provide updates to the stakeholders during the duration of the project. In addition, we utilized tools learned from human factors engineering to make sure our interface is user-friendly and easy to use. To complete the report, we relied on tools learned from industrial costs and controls, engineering economics, test design and analysis, as well as the ergonomics lab. When designing the database, Microsoft Access was chosen as the ideal software to create the check-in, check-out system. Microsoft Access's ability to provide an easy-to-navigate yet powerful user interface, along with its capacity for large sets of data, makes it the ideal candidate for our project. Additionally, a Microsoft Access database was used by Mustang 60 and the Arrow Hanger, so there were less possible complications when implementing the database update. Microsoft Access also has the capability of allowing data visualization within the application, so user-friendly forms were easily created to display the collected data. The option to export the forms to other formats such as Excel, PDF, and CSV files was also a big bonus. Another aspect of our project is the design of the physical check-in, check-out system. New card ID scanners were determined to streamline the check-in, check-out process by removing the requirement of having a shop tech be present when users needed to check in and check out.
To achieve our desired state, we first had to enter the old database and clean out all of the previously implemented VBA structures in the database. What we were able to do then is replace those functions with query by example functions, which created an actual relational database. With this added ability now, we were able to add functionality to the administration page. What this meant is we were able to display accurate student information without system errors showing -1 million hours, for example. In this administration page, we added a student search subquery that was functional. Now you can search by college, date, or tag certification, and then actually display that information and then have the ability to export it into an Excel file. We were also able to implement a card scanner for students to use when checking in and checking out. Each student would be printed a card that had a unique identifier to them, and once scanned, it would drop that information into the database and they would be signed in or out. To give some visual context to what I was discussing in the previous slide, we've displayed the old administration page compared to the new administration page. On the left with the old admin page, you can see that the subform below all the search criteria listed is blank, and that's because there is zero functionality. None of the buttons that you could click up above it worked or did anything. So this admin page right here was actually useless. It was just taking up space in this database and the shop techs were not using it. What we did is we cleaned it up and actually made it functional on the new administration page. We took out a lot of search query information that we deemed was either unusable or unhelpful after feedback from the shop techs, and we were able to then create a usable subform below. You can then search the database for student hours based on their major or the dates that they might have checked in or their tag certification or all three. And then from that, we're able to then have a function to export this data into an Excel file. What this does is this gives us the ability to show donors and sponsors club or student hours and have some hard concrete evidence to the hard work that students are putting in.
After implementing our database, tests were performed and feedback was given to determine the effectiveness of our proposed database. As a result, there were less user and systematic errors reported within the updated database. This reduction in errors has caused less time being wasted fixing corrupt data. The new ID scanner has reduced the wait time of when students are checking into and out of both machine shops. Furthermore, shop techs can be utilized elsewhere rather than checking students in and out of the shop. The updated database's ability to quickly export accurate data saves wasted time that had previously been spent correcting the data. Without the requirement to data mine the corrupted data, the shop can present these reports more often to potential donors as well as their various sponsors. The aesthetically pleasing and user-friendly database has made it easier for shop techs to do various key tasks such as searching up student information. When determining the cost benefit of implementing our updated database, it was estimated that the manpower saved was 5 to 10 minutes daily, in addition to 5 hours of manpower quarterly when data mining for files for quarterly reports. With the wage of shop techs increasing to $12 an hour beginning in 2019, the yearly savings equals roughly $639. Besides the cost benefits of the implemented database, our sponsor Eric Pulse has said that this database will be great for the shops. It will save them lots of time trying to find out how many hours a student has logged. Furthermore, the card reader that has been implemented can be utilized in future additions to the system that have been in discussion.
The final section in this project was giving future direction to the machine shops on what they can do next with the database. What was recommended was doing a tool tracking system. What this means is that they will be able to assign a tool to a student when they are using it. By doing this, they will be able to locate when a tool is missing. They will also be able to track the hours of each tool and be able to know when to service and when to replace each tool if needed.